Hello everyone. Today we're going to be talking about TLC or thin layer chromatography. So to start off with, we're going to talk about how they set up the experiment and what the different results actually indicate. So if we look at this one, the thin layer chromatography, what it's used for, it's used to separate mixtures and it determines the composition and purity of substances. So if we look at the setup here, there's a few different terms you need to be familiar with. So there's a thing called the stationary phase. Now, the stationary phase is just the thing that the sample is put on. So in this example, it's this paper thing here. So this white rectangle, that actually represents the stationary phase. It's just the paper or the solid or silica sort of material. And the mobile phase, that is the solvent. Now the solvent is actually labeled in this diagram. It's this thing down the bottom. Okay. Now, what will happen is that solvent will move up the surface. So it'll move through this paper or the TLC plate and it'll move up this way. Okay. That's due to capillary action. So the material of the TLC plate allows the solvent to move along it. Now, when the solvent moves up the plate, the sample, which is this little red dot, will be moved along with the solvent because it'll carry it along with it. So like as the solvent moves up this way, then also the sample will move up it as well. Now the distance that it moves, that depends on the sample that is in the solution. Okay. Now, substances, it depends on the strengths of the interaction. So substances that interact strongly with the stationary phase, so it interacts strongly with the TLC plate, they move more slowly, okay? And substances that interact strongly with the mobile phase or the solvent, they'll kind of get pulled more along the TLC plate. So it'll end up over here somewhere if it interacts strongly with the TLC plate. But if it doesn't interact strongly, then it might end up around here. And that means that it interacts more strong with the TLC plate. So those interactions can include intermolecular forces such as polarity and hydrogen bonding. Now, after that solvent has moved up the plate or the paper, the different components appear as separate spots. So if you have one spot, so for example, this one's moved and now there's a spot here. If there's only one spot, then that means it is a pure substance. The sample was a pure sample. But if there's multiple different spots going up the TLC plate, then that means that it was a mixture. So the substance was a mixture. Okay. Now, one other way we can analyze the sample is a thing called the retention factor or the RF value. And that calculation is done by the distance traveled by the substance divided by the distance traveled by the solvent. So I'll write that formula down now. Alright, so that's the formula for the retention factor there. And the distance traveled by the solvent, so that is the solvent will move up this way, and it might move up the plate until about this point. So then that distance there would be down the bottom, and then the distance traveled by the substance depends on where that dot has gone to. So if it's gone to there, then the distance would be this distance here. That would be on top there, okay? Now, that retention factor, it'll always be between 0 and 1, and it can be compared to known values to help identify components. So you can compare that to a known retention factor to help establish what that substance might be. So to summarize, chromatography separates substances based on their interactions with the stationary and mobile phases. And analysis of spots and the RF values help determine the composition and also the purity of the substance as well. All right,